In this video, we will look at rationalizing denominators that have a monomial square root. What we mean by rationalizing the denominator is we want to have no radicals in the denominator or bottom of the fraction. If we do end up with radicals in the bottom of the fraction, we can clear them by multiplying by any extra needed factors in the denominator. Of course, as we do this, we'll need to multiply by the same thing in the numerator. Before we do this, though, it may be helpful to reduce first. By reducing, I mean both the radicals and fractions. Let's take a look at an example where we have to reduce first and then rationalize the factors that remain. Putting this all under one radical so we can reduce the fraction, we have 7ab over 6ac squared. Notice the a's can divide out. And now let's bring it back to separate radicals. We have the square root of 7b over the square root of, finding the prime factorization of 6, 2 times 3, c squared. The only thing we can pull out of a radical, as we simplify the radicals, is the c squared. Dividing the exponent by the index, we get 1c coming out. We now have the square root of 7b over c times the square root of 2 times 3. Now we are ready to rationalize this denominator, or get rid of the radical that ended up in our simplified denominator. The way we do this is we multiply by any missing factors under a radical in the denominator. Square root has an index of 2, meaning we're going to divide the exponents by 2. We currently have 1 of the first number 2, which means we need one more 2 to rationalize. Similarly, we have 1, 3. To divide that exponent by 2, we need one more 3. Now we will have two 2's and two 3's in the denominator, which can divide by the index of 2. Of course, we will do the same thing in the numerator, multiplying by the square root of 2 times 3. When we do this in the numerator, we have 7 times 2 times 3, which is 42b. In the denominator, we'll have 2 squared, which comes out as a 2, and 3 squared, which comes out as a 3. Notice there is no radical remaining. We have 2 times 3, or 6c. This is our final rationalized answer, as there is no radical in the denominator. Let's try another example where we rationalize the denominator and simplify the fraction. In this problem, you can see that 5 and 15 reduce, leaving a 3. The x's divide out completely. And the y divides with the y cubed, leaving y squared when we subtract the exponents. We now have the square root of y squared over the square root of 3z. Again, we can simplify the y squared, pulling it out of the radical as simply y. Y over the square root of 3z. Now, to rationalize the denominator, to get rid of the radical, we'll multiply by the missing radicals. To divide by an index of 2, we've already got one 3. We need one more 3. Similarly, we need one more z. Doing the same thing in the numerator, so that our numerator is y times the square root of 3z. In the denominator, we have 3 squared, which comes out as a 3, and z squared, which comes out as a z. There is now nothing left in the radical, and we have just 3z in the denominator. By clearing the radical out of the denominator, we get our final simplified solution.